Alrighty guys, we're going to do a video explaining the Unit 0 practice test for Algebra 1. On this first part of the video, we're going to talk about classifying the following numbers, and there's a group of numbers on this practice test that involves classifying. And in order for us to really understand classifying, we have to pretty much have this chart memorized right here. Just to reiterate, natural numbers are the numbers that you learned naturally when you were a little kid, right? 1, 2, 3, 4. And then you grew up a little bit more and you understood the number 0, right? You didn't start when you were 2 years old counting 0, 1, 2, 3, 4. You just started 1, 2, 3, 4. You learned that naturally. That's why they're called natural numbers. You grew up a little, you learned about the number 0. And the number 0 is the number with the biggest whole in it. So when you include the number 0, then you're talking about whole numbers. And you grew up a little bit more and you realize that not all numbers are positive. We also have negative numbers. So we have the integers when you include negative numbers. And you grew up a little bit more and you realize that not all numbers are perfect, like 1, 2, or -1, -2, -3. Sometimes you end up in between, which involves decimals and fractions. Now, decimals and fractions are technically called ratios. So the word ratio is inside the word rational number, and that should remind you that ratio means fraction. So if you have a fraction or a decimal, because fractions are technically decimals, you have a rational number. And we also need to think about the word rational itself compared to irrational. Again, the word rational compared to irrational, right? Rational means that it makes sense, you understand it. Irrational means that it's a crazy decimal number that doesn't repeat, that has no pattern, that continues forever. So once again, rational numbers, they make sense. Like, you know what 3/4 of a tank of gas is, or 3/4 of a pizza, right? You also know if you turn 3/4 into a decimal, first of all, a fraction is a division problem. 3 divided by 4. If you do 3 divided by 4, that'll become 0.75. By the way, that's a skill right there, turning a fraction into a decimal. But you know what 0.75 is. That's like 75 cents. It makes sense to you. That is rational. As opposed to pi, which is a crazy decimal, or e, which is a crazy decimal, it doesn't repeat, or the square root of any non-perfect square number, that also is a crazy decimal that has no pattern, that doesn't repeat. Those are irrational numbers, okay? So rational numbers make sense, irrational numbers don't make sense. Rational numbers, you think of fractions, which technically are decimals, and they make sense, right? It is possible for me to ask you to classify a certain number, and when I just say classify, give the most specific group that it belongs to. So for example, if I said classify the number 0, it would be a whole number. But there's a difference in the instructions. If I were to say, give me all the groups that the number 0 belongs to, well then 0 is not natural, 0 is whole, but it's also an integer, and technically it's also a fraction. You could put 0 over 1, so that would make it rational. And not only that, it makes sense. You understand what the number 0 is. So having this in mind, having this knowledge in mind, we should now be able to classify all these examples that we're about to do, and these are all part of our questions in our quiz. So here we go. The square root of 25, I ask you to classify it. Now, if you're thinking, oh, square root, that means that it's irrational, right? A square root is irrational. False. You have to know, or you need to be able to identify that when you have the square root of a perfect square number, this is a perfect square number, the answer is perfect. It's 5. So what I'm really asking you to classify in this case is the number 5, and we know that that is natural. Okay. Now notice that the instructions say classify. It doesn't say state all the groups that it belongs to or select all the following that it belongs to. Right here it's just classify. So pi, we know that pi is a crazy decimal, so that continues forever, that has no pattern. So that's what we call irrational. Okay, let's try some more examples, and notice over here we have a different type of instruction. It says, which of the following is a whole number? So we got to select which one's a whole number. Now, when you look at this, you're going to look at the 0 and be like, oh, whole, that's a whole number right there. So you're going to circle this guy All right, circle that guy, and that's your answer. But if you hit enter, technically it's wrong because there are more numbers that are also whole numbers. Obviously, 1/2, that's a fraction, it's a ratio, that's a rational number. 7 is also a whole number. Now you might be thinking, wait a minute, isn't that natural? Yes, it is natural, but is it whole? Yes, it's whole. And 5, yeah, it's natural, but is it whole? Yeah, it's like me saying, hey, you live in the Imperial Valley. That's true, like you live in the Imperial Valley. If not, you wouldn't be coming to school here. So again, it's not as specific as possible, but right here the question is, which of the following is a whole number? 7 is a whole number. Even though it's not that specific, it is. And 5 is also a whole number. So you would select those 3 and then hit enter, and you'll get full credit on this question. Moving on, number 4. It says, select all the groups that the number 8 belongs to. Okay, so let's select all the groups that the number 8 belongs to. First of all, in my mind, I would like to go through this again, and I would just like to think about the number 8. Well, I know 8 is natural. I know 8 is also whole. It's an integer. It's rational. It's definitely not irrational. So 8 is all of these. So let me look for all those on the list provided. Is it rational? Yes. 8 makes sense, right? I know what $8 is. Is it a whole number? Yes. Is it imaginary? Nope. Is it irrational? No, I mean, it's totally rational. It makes sense. It's not crazy. It's not a crazy decimal. How about an integer? Yes, it's an integer. Now you might be thinking, wait, aren't integers negative numbers? Yes, but it also includes positive numbers that are not decimals or fractions. Obviously, none of these is incorrect. So you would select those 3 and then hit submit. So yes, we're going to have some multiple choice questions. We're going to have some select all that apply. In this case, select all the groups that the number 8 belongs to. You select those 3, and then you move on. Okay, so let's move on to the next one. Same type of question, select all the groups that the number -8 belongs to. Okay, so once again, let's just go through this and let's think, well, what is -8? Is -8 a natural number? No, you didn't learn that naturally. Is -8 a whole number? Nope, there are no negatives involved. Is -8 an integer? Yes, it starts existing right here, and it's also rational because I could make -8 into a ratio. I could put it -8/1, that'd be a fraction. I could make it even a decimal, -8.00. So yes, -8, it makes sense. I understand -8 is kind of like owing $8. So anyways, let's go through and check all of those off. Is -8 rational? Yes, it is. It makes sense. Is it a whole number? Nope, it's not. Is it imaginary? Nope, it's not. Is it irrational? No, it makes sense. I know what -8 means. Is it an integer? Yes, it is. And of course, it's not none of these. So those 2 are the only correct groups that the -8 belongs to. So you would hit submit after selecting those 2. Moving on to the next one. So on this next one, they're asking us to classify the square root of 8. So remember, square roots, if you do the square root of a perfect square number, you get a perfect answer. And this is not a perfect square number, okay? So if I actually did this on a calculator, which I'm doing right now as we speak, I'm typing it into the calculator, that gives me this crazy decimal, all right? It's 2.828427125, and it continues forever. That's a crazy decimal. That's what we call irrational. Irrational. All right, so the square root of 8 is irrational. Now, if I were to ask you what's the square root of 36, well, that's really asking you, if I asked you to classify the square root of 36, well, that would be asking you to classify the number 6, and we know that that's natural, okay? So be careful with that. Let's move on. On this next section of this video, we're going to be adding, subtracting, multiplying integers. So the key to adding, subtracting, multiplying integers is to know when you're actually thinking of money, which is adding and subtracting, and when you're actually multiplying. Okay, so we are multiplying when there is a dot between the terms or when there's nothing between the terms. Okay, so what's between the 5 and the 7? There's a minus sign right there. Okay, what's between the -2 and the 6? There's a minus sign right there. And even if I were to have, like, let's say 3 plus -2, Is there something between the two numbers? Yes, there's something. Anytime there's a symbol between the two terms of addition or subtraction, that's when we're adding and subtracting. If there is no symbol, like for example, if I were to erase that plus sign and put parentheses around the -2 and put that right there, there's no symbol between the two. That means I need to multiply right here, okay? So multiplying, you need to remember the rules. I would say that a negative times a negative equals a positive. Obviously, a positive times a positive. If I say 3 times 2, you already know it's 6. But right here we have a -3 times, or positive 3 times -2. That answer is -6. Now this is just an example, not the actual examples that are on the quiz. Let's do that. So once again, on the quiz, on the practice test, you're going to look for the ones that you're actually multiplying, and that would be numbers 3 and 4. There's nothing between the -6 and the parenthesis. There's nothing between the -3 and the parenthesis. So right here we're multiplying. Okay, we're multiplying on those two. Up here there's something between the 5 and the 7. Up here there's something between the -2 and the 6. So right there you're thinking of money. So let's think of money on the first one. You have 5, you owe 7. You could pay off the $5 that you have and you're still going to owe $2. So 5 take away 7, you have $5, you owe $7. You can't completely pay them off. Give them the $5 that you have, you're still going to owe $2. Next one, you owe $2, you owe $6, you're going to owe a total of $8. Okay, you owe $2. If you owe somebody $2 and you owe somebody else $6, hey, guess what? You owe a total of $8. Right here, I am not thinking of money. I am not thinking of money. Why? Because I'm actually multiplying, because there's no sign between the terms. So right here I'm multiplying. What's a negative times a negative? It's a positive. So I already know my answer is positive, and you don't even have to put a plus sign. 6 times 2 is 12, so positive 12. And when you type this in, I wouldn't even put the plus sign. I would just type in 12, because that automatically says that it's positive 12. Right here you have a negative times a positive. Okay, so remember, a negative times a negative equals a positive. But when the signs are different, the actual answer is negative. So -3 times 5, that's -15. Okay. I hope this helps. When are we multiplying? When there's no sign between the terms. When are we thinking of money? When there is a sign between the terms. And again, it doesn't have to be a negative. It could be like 5 plus -7. Right there, there's a sign between the terms, so you're thinking of money. This means you have $5. This means you owe $7. That would mean that your answer is -2. You owe $2. All right, I hope this helps. Let's move on to the next section. Exponents is what we're covering here on this section of the video. Now, the important thing about exponents is this, that parentheses make a difference. Let's begin with something very basic. 2 to the 3rd power. What the heck does that mean? Okay, well, the 2, that's what we call the base. This number 3 up here, that's a little bit smaller, that's up on top right, that's called the exponent, or the power. Power or exponent. Okay, now the exponent tells you how many times to multiply the base with itself. Well, let me repeat that. The exponent tells you how many times to multiply the base with itself. So I am going to actually write this out. The base is the number 2, and I need to multiply it with itself 3 times. 1, 2, 3. Okay? And whatever answer I get, that will be my answer to 2 to the power of 3. A lot of students make the mistake of thinking, oh, 2 times 3 is 6. Wrong answer. 6 is not the right answer. It's really 2 times 2, which is 4, right? 2 times 2 is 4, and then 4 times 2 gives you 8. So the answer is 8. Okay, I hope that helps. Let's go through some actual questions that you will see in the practice test. Here we go. Now, when we look at these, there's a big difference with parentheses. Parentheses matter, okay? So the parentheses tell you that the base does include the negative sign. Over here, there are no parentheses. So this is telling us that the negative sign doesn't really belong to the 5. You need to do 5 squared first and then put a negative sign on your answer, okay? So once again, when you have parentheses, around a number that has a negative, it's including the negative number. So when I think I need to write this 4 times, multiply this base with itself 4 times, I am actually going to write out parenthesis -2, parenthesis -2, parenthesis -2, parenthesis -2. However, when I compare it to the next question here, it says 5 to the second power with a negative in the front. That's where I go 5 squared. What is 5 squared? That's really a 5 times 5. And then what about this minus sign? I'm just going to bring it down and put it in front of my problem. Okay, so that's the big difference. Parentheses do matter, all right? So parentheses, it's including that negative sign. So when you write out your base 4 times, it's -2 times -2 times -2 times -2. When you don't have parentheses around that negative, then you really do exponents first, 5 squared, that's 5 times 5, and simply bring down that negative to the front, okay? So let's see the answer to number 1. On the first one here, we have -2 times -2, that's +4, times -2 times -2, that's a -8, and then another -2 right here, 8 times -2, that will be a +16, okay? So the answer to number 1, -2 to the 4th power, that is +16, okay? Moving on to number 2 here, we have 5 squared, that's 5 times 5, bring the negative down. So that's really a -5 times a +5. The answer there is -25. A negative times a negative equals a positive, right? Like over here, -2 times -2, that was a +4. But right here, a negative times a positive, that's a negative, all right? Anyway, we now have this very interesting question, -1 to the 28th power. Now, it would be ridiculous if I started doing, okay, this is including the negative sign, the base is -1, so imagine if I went -1 times -1 times -1 times -1, all the way 28 times. That would be ridiculous if I wrote that out. But the bottom line is, I already know what 1 times 1 times 1 times 1 times 1 times 1 is going to be 28 times. It's going to simply be 1, because 1 times 1 is 1. It doesn't matter how many times you multiply it by 1, it's still going to be 1. The real question is the answer going to be a +1 or a -1? Keep in mind that a negative times a negative equals a positive. So let's go back to the first one here. When I look at this negative and that negative, that gave me a positive, okay? Now, if I were to do this negative times that negative, that'll also give me a positive. So what's happening here is, if you recognize, you could pair up two negatives. So if you're able to pair them up, that means that your answer is going to be positive. Now, what does it mean for you to be able to pair up something? Well, is this exponent divisible by 2? Is it an even number or is it an odd number? If it's even, if it's divisible by 2, that means you'll be able to pair them up and have a positive times a positive, which will give you a positive. If you have an odd number, then you're not going to be able to pair them up. Let me show you. Like if I had a -1 to the 3rd power, okay, that'll be a -1 times -1 times -1, and you'll be able to pair up just these two, which gives you a positive, but you'll have a negative left over, and of course a positive times a negative will be a negative. So it's pretty simple. When your power is even and your base is negative, the negative sign is included, then your answer will be positive. Once again, when your power is even and you do have a negative that's included in your base with parentheses, then you're going to be able to pair them up and your answer will be positive. Why? Because a negative times a negative is a positive, negative times a negative is a positive. But if your exponent is odd and you have a negative sign included in your base, then you're not going to be able to pair them up. Look, I paired up these two, but this one's left over. So there's an odd amount of negative numbers, which means that your answer will be negative. So right here, 28, is it even? Is it divisible by 2? The answer is yes. So if I were to expand it 28 times, I'll be able to pair up negatives all the way through and have nothing left over, which means that my answer will be a +1. I hope that helps. I hope that makes sense. Moving on to number 4, we do have a negative sign included in the base. I want to expand it. -3 times -3 times -3. That's because the exponent told me to write this base 3 times. 1, 2, 3. There it is. Now simply do the math. What is -3 times -3? That's a +9. What's +9 times this -3? That's a negative 27. So this answer, negative 3 in parentheses, to the third power, the answer is negative 27. Last but not least, we have 1 to the 6th. Don't get confused. Right here, there are no parentheses. There are no parentheses including this negative sign. So what this really is 1 to the 6th power, 1 times 1 times 1 times 1 times 1 times 1, 1, 2, 3, 4, 5, 6, and then with this negative sign just slapped out here in the front. So obviously that answer will be negative 1, okay? I hope this makes sense and I hope this helps. Once again, parentheses really do make a difference when it comes to your answer being positive or negative. If you have parentheses with the negative on the inside and your power's even, then you know you're going to be able to pair them up. You know your answer will be positive. Why? Because a negative times a negative is a positive. If you don't have parentheses, including that negative sign, then you just do the 5 squared, bring down the negative, okay? If you do have that negative sign in parentheses, is this an even number, which means are you going to be able to pair them up? And the answer is yes, because it's divisible by 2, so that means that your answer must be positive. If that would have been a 27, this would have been a negative 1 answer. Moving on. On this section of the video, we're going to add, subtract, and multiply fractions. Let's begin with multiplying and dividing fractions because that's the easiest thing that we could do. Here we go. Where are we? Here we go. So these are straight from the practice test. What would the simplified reduced answer be to this guy right here? Well, again, we are multiplying because there's no sign between the number and the parenthesis. And how do we multiply fractions? It's pretty simple. You could either multiply the top with the top. 1 times 2 is 2, 2 times 5 is 10, and then reduce, okay? You got to reduce, right? You got to simplify it. So you reduce the 2/10, reduce it by 2, reduce it by 2. 2 divided by 2 is 1, 10 divided by 2 is 5. There's your answer, 1/5, okay? That's not the easiest way of doing it. An easy way of doing this is recognizing that there's a 2 up on top and a 2 on the bottom, and 2 over 2, 2 divided by 2 is 1. So whenever you have the same identical thing up on top and the same identical thing on the bottom, you could cancel them out. Of course, that's only when you're multiplying, not when you're adding or subtracting. But right here, yes, you could cancel out the 2 with the 2, and what do you have left over? 1 on top, 5 on the bottom. That's exactly what we have here, 1/5, okay? So this one will be multiple choice, and that is a positive 1/5, and that would be your answer right there. Okay, let's move on. How about this one, dividing? Okay, so, and it also says reduce if you could. When you divide by a fraction, you really multiply. You change that to multiplication. You multiply by the reciprocal of the second fraction. So you got to flip the second fraction. That should have been in your notes. That should have been covered in class. So this first fraction you're not going to mess with. It doesn't matter if it's a fraction or a number. You don't mess with this first term. But when you divide by a fraction, you really multiply by its reciprocal. Again, when you divide by a fraction, you really multiply by its reciprocal. So you change it and you flip it. Change it to multiplication, flip the second fraction. Not the first fraction, only the second fraction. So we just said the first fraction, nothing happens. The division changes to multiplication, and the 5/3 becomes 3/5. Now, could we cancel anything? Is there a 2 up on top and a 2 on the bottom? No. Is there a 5 on top, 5 on the bottom? No. If you would have canceled these 5s, it would already be wrong. You got to change it and flip it first, and then see if you could cancel anything out, which you cannot. So it's simple. Just multiply the top with the top. 2 times 3 is 6. Bottom 5 times 5 is 25. 6 over 25. That is your final answer. You can't really reduce it. You can't reduce by 2. Can't reduce by 3. That's it. There's your answer. 6 over 25. 6 over 25. Looking at our answer choices, there is no 6 over 25. So the answer must be that none of these are correct. None of these are correct. Let's move on. Right here we have negative 6 divided by 3/2, and this one is a fill in the blank. Now if you're thinking, well, wait a minute, how am I going to type in a fraction as the answer? Well, first of all, let's find out what the answer is. Okay, and we said when we divide by a fraction, you really multiply, so that's going to become multiplication by its reciprocal. So the 3/2 becomes 2/3. And we know that this first number, you don't mess with it, just bring it down, -6. So what you really have here is -6 times 2/3, okay? Change it to multiplication, flip the second fraction, that's what we got, -6 times 2/3. What is in front of, or what is below the -6? Well, there's technically an invisible divided by 1. You could make it look like a fraction, so you could multiply the top with the top and the bottom with the bottom, if you want to. Another thing you could do is realize that the 6 is on top and the 3 is on the bottom. Anyways, let's go with the first option, all right? Let me show you. What is -6 times 2? That's, or you could even start with this, a negative times a positive. You already know your answer is going to be negative, okay? So that's a negative sign. What is 6 times 2? That is 12. 12 up on top. And on the bottom, what's 1 times 3? That's 3 on the bottom, on the denominator. So what we have here is the answer, -12/3. But remember, a fraction is really a division problem. So 12 divided by 3, that's actually 4. And let's not forget about the negative sign, all right? So the answer is -4. There's my answer, okay? That's one way of doing it, multiplying the top with the top and the bottom with the bottom, and then reducing at the very end or dividing at the very end. Or another option of doing it is recognizing right from the start that 6 is on top and 3 is on the bottom, and 6 is divisible by 3. 6 divided by 3 is 2. So imagine that. 6 divided by 3 is 2, so there's a 2 up there, and it's technically a -2 because of the negative sign. So what we really have here is -2 times +2, and -2 times +2 is the same answer, -4. Okay, so it's totally up to you which way you want to do it. There's many roads to the same place in math. You could either multiply top with the top, multiply first, and then reduce, or you could reduce first and then multiply. It's totally up to you. Moving on. Now that we've covered multiplying and dividing fractions, which is way easier than adding and subtracting fractions, now let's move on to the more challenging part, adding and subtracting fractions. So we do have, whoops, the answers are there. Pretend you didn't see these answers, okay? We do have these questions, and again, pretend you don't see that. It's super easy when you have a common denominator. When you have a common denominator, it's really easy to add or subtract fractions, because when you have a common denominator, all you're really doing is writing it over, that denominator, and simply doing 5 take away 2. 5 take away 2 is 3. So the answer is 3/16, and that's what we saw down here, 3/16. That's why it's in green. Okay, it's similar to when we compared fractions. Like, let me create just two random fractions here. Again, this is not part of the problem anymore, but let's just create 2 random fractions. Let's go with 43 over 55, and let's go with, let's say 3/5, okay? So the question is, which one is bigger, right? Is it a greater than symbol? Is it a less than symbol, or are they equal to each other? Well, in order to compare fractions, you need a common denominator. So you rewrite your 2 fractions, and the way to do it is go to your bigger denominator and see if you could change that one to become like this one. That way you don't have to mess with that first fraction that has the greater denominator. So right here, yes, the 55, the 5 could change to a 55, so we're not going to mess with this fraction at all, because 55, it works for the common denominator. Now on the other one, yeah, multiply by 11, and multiply by 11, and you'll get 33 over 55. And now that you have the common denominator, you could compare 43 and 33, and obviously 43 is bigger, so 43 55ths is greater than the 3/5. Anyways, that's just a similar type of problem. You need a common denominator to compare fractions. You need a common denominator to add or subtract fractions. Multiplying is way easier because you just multiply top with the top, bottom with the bottom. So for example, if this said multiply 7/10 times -2/15, the answer would be -14 over whatever 10 times 15 is, which would be 14 over 150, and then you reduce. But anyways, we're not multiplying. Right here, we are subtracting, and we need a common denominator. Okay, so once again, the process is to go to your bigger denominator, 15, and then say, could I change my smaller one to become the bigger one? 10 times something give me 15? No, because 10 times 2 is 20. So it's already too big. So if 15 didn't work, then take that bigger denominator, multiply it by 2. 15 times 2 is 30. Okay? Could I change 10 to become 30, 15 times 2? The answer is yes. So 30 is the common denominator. And what I like to do is right below, I like to write the common denominator 30, that I'm going to change them to 30. And then I ask myself, how do I change the 10 to become 30? I multiply by 3, multiply the top by 3. That'll be a 21 with a minus sign between the two. And then 15, how do I change that to a 30? Multiply by 2, multiply by 2, that'll be a 4 over here. And now we have the problem 21 over 30, which is the same thing as 7/10. Take away 4 over 30, which is the same thing as 2/15. And my answer will be over that common denominator 30. All I have to do is actually try to do 21 take away 4, which will be 17. 17. So my answer is 17/30. Now, whenever you have an answer, try to reduce by 2. Is 17 divisible by 2? No, it's 30, so that you can't reduce by 2. How about dividing by 3? Is 17 divisible by 3? No. Okay, so you can't reduce it at all. There's my answer, 17 over 30, and that's why the 17 over 30 is the one highlighted in green right there. Alrighty, let's move on. Adding and subtracting these fractions, again, we need a common denominator. We need a common denominator. So once again, let's go to the 6 and see if we could change 4 to become 6. 4 times 2, is that 6? No, 4 times 2 is 8, so it's already too big. So 6 didn't work, but let's stick with this bigger denominator, multiply it by 2, that would be 12. 6 times 2 is 12. Could I change 4 to become 12? Yes, I can. So I know that my common denominator for both fractions will be 12, And I know that there's a plus sign between the two. And how do I change the 4 to become 12? Well, I'd have to multiply both top and bottom by 3, right? So up on top, I'll get 3 times 1, which is 3. On the other fraction, how do I change 6 to become 12? Well, I multiply by 2. So I multiply the top by 2, and 5 times 2 is 10. Okay, so now that I have a common denominator, 12 and 12, now I could actually focus in on adding the numerators, 3 plus 10, which is 13. So my answer is 13 over 12. Okay, now if you look for 13 over 12 on the multiple choice, you're not going to find that. That's because this is an improper fraction, and I purposely put this question on here to show you and remind you how fractions work. Fractions are really division problems. So the 13 goes inside the division box, 13 divided by the number 12 that goes on the outside. And the question is, how many times will 12 go into 13 without going over, right? 12 times what gets you close to 13 without going over? The answer is obviously 1. Okay, so 12, 1 times 12 is 12. Subtract, you will have a remainder of 1. Now, if you did want to change this to a decimal, you would put a decimal 0 and then drop the 0 and put a decimal up here and continue adding zeros and dropping zeros. But we're not trying to change it to a decimal. We're changing it to an improper fraction. Improper fraction to a mixed fraction. And how does that work? You do the long division, whatever's left over, you put that remainder over the original divisor 12. Again, remainder over the original divisor 12. So your answer is 1 and 1/12. And that's exactly what is in green right there on the multiple choice, 1 and 1/12. Next question, we are adding and subtracting. We're not multiplying. Why? Because there's a sign between the terms. There's a minus sign between the parentheses. And whenever we start thinking of money, of course, whenever you have a minus minus, change to a plus plus. You see there's still a sign between the parentheses, so you're not multiplying. Now, whenever you are adding fractions or subtracting fractions, you need a common denominator. Again, the bigger denominator is 12. Could I change 4 to become 12? The answer is yes. All you have to do is multiply the 4 by 3. So we know the common denominator will be 12. It will be 12, okay? So how do I change 12 to become 12? I don't do anything, right? It's already 12. So this first fraction, the negative 5/12, is still going to be negative 5/12. The other one, how do you change 4 to become 12? You multiply by 3, and that'll be a 3 up on top. And of course, you have a plus plus, So you could just put plus one time. I mean, you could put plus plus if you want. But now that we have a common denominator, our answer will be over that common denominator 12. So what is negative 5 plus 3? Negative 5 plus 3 is negative 2. So there's our answer. However, we could reduce that answer. I know they're both numerator and denominator divisible by 2. Divide by 2, divide by 2. Your answer will be negative 1 over 6. Negative 1 over 6. And you could put that negative sign out in the front, or of course you could leave it up on top. Either one of these are totally acceptable. When we look at our multiple choice answers, it's written out in the front. Okay, so negative 1/6 is the correct answer to that one. Moving on. On this next section of this video, we're going to focus in on changing fractions to decimals and to percents, or vice versa. Let's begin with these guys right here. These are ridiculously easy. It says convert 9% to a fraction, which is really easy because the word cent means 100. So if I say 9%, that's really saying 9 per 100, which really means 9 divided by 100, 9 over 100. So convert 9% to a fraction, that's 9 over 100. Try to reduce it if possible. You can't divide by 2, you can't divide by 3. That's your answer. Too easy. That's like a free point. Anyways, the next one, convert 40% to a fraction. That's going to be 40 over 100. Could you reduce that? Yeah, absolutely. Whenever you have zeros right on top of each other like this, you could cancel out those zeros and you really have the fraction 4/10. But then again, you could reduce that even further by dividing both top and bottom by 2, giving you your final answer 2/5. 2/5 cannot be reduced any further, so the correct answer to the square root of 40 is 2/5. Moving on, convert 0.13 to a fraction. That is pretty simple. All we have to do is remember numbers and their place values. So this was straight from a previous notes from a previous video. You got to know that this is the 10th position, this is the 100th position, this is the 1000th position. So if I were to ask you change this decimal to a fraction, you would just write the numbers that you see, 527, over that last number. It's over thousandths, so it's going to be over 1,000. Okay, it's that simple. Now, what if you didn't see that? What if you just saw, like, let's say, what if the 7th was not there? Then how would you change this to become a fraction? 0.52. Well, you write 52 over, what's that last one? That's the 100th position. So you would put over 100. And of course, always reduce if possible. In this case, you could reduce. In this case, I don't believe you can. Anyways, let's go back to the actual questions that are on the test. Convert 0.13 to a fraction. This is the 10th position. This is the 100th position. So it's pretty simple. Your answer will be the number 13 over the 100th position. So 13 over 100. Now, out of all these questions, converting fractions, decimals to percents, number 4 is the most challenging one. It says convert 3/8 to a percent. Okay, so first of all, 3/8 is a fraction, and I need to convert that to a decimal. So how am I going to do that? I need to recognize that a fraction is really a division problem. It's really the number 3 inside the division box and the number 8 on the outside of the division box. So we're going to convert it to a decimal first. Okay, and how do I do that? Well, I put on a decimal right here after the 3 and put a 0. That way it looks like a 30. That way I could think 8 times what gets me close to 30 without going over. But then again, if I just put this decimal and 0, I need to take that decimal and put it up here, and that will be the decimal that it converts to. So 8 times 3 is 24. So I have a 0.3 so far. That's 24. You're going to subtract, you're going to have a 6 left over, and then again we add a 0 and drop a 0. And then we got 8 times what gets us close to 60 without going over. 8 times 7 is 56. And when you subtract that, you'll have a 4 left over, and again add a 0, drop a 0. And 8 times 5 will get us that 40. And of course right there, the remainder 0, we are done. Converting 3/8 to a decimal will be 0.375. Now, they didn't ask us to convert to a decimal. They told us to convert 3/8 to a percent, but you have to go from a fraction to a decimal and then to a percent. Remember, dividing by 100 really moves the decimal place over 2 places. But if you're converting this number back to a percent, then you'd have to move 2 spaces in the other direction, okay? Let's think about this. When I say 0.95, that's almost 1 whole. That's almost 100%. So a decimal converted to a percent, you would move it 2 spaces over, and that would be 95%. So the decimal 0.95 becomes 95%. And that makes total sense because the number 1 would mean 100%. If you have 1 whole, that's 100%. You're not missing anything. So right here, we have a number already, right? And we're gonna change it to a percent. So just like down here, we had a number, you wanna change it to a percent, you moved it 2 this way. So we need to move this 2 this way, and that will be the answer 37.5%. So 3/8 changed to a percent will be 37.5%. That's probably the most challenging one out of this whole section. We are finally to the last part of our video, giving a decimal approximation of the following radicals. In order to be good at this, I recommend creating a perfect square number list. Just simply think 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 4 times 4, and you create this list as far as you need to go. Now from here, we need to recognize this truth that the square root of a perfect square number is a perfect answer. The square root of 49 is 7. The square root of 81 is 9. The square root of 4 is 2, right? If you take the square root of any of these perfect square numbers, you're going to get a perfect answer, a nice, beautiful, natural number. So we are going to use this perfect square number list to help us approximate answers of these non-perfect square numbers, right? So the square root of 30, we know that's irrational. It's a crazy decimal that continues forever. But knowing this fact that I could use a perfect square number list to find the square root of non-perfect square numbers, I could give an approximation, a decimal approximation. So where would 30 land? Well, 30 it's bigger than 25 but smaller than 36. Is it super close to 25? Is it super close to 36? Or is it kind of in the middle? It's kind of in the middle. So the answer to the square root of 25 is 5. The answer to the square root of 36 is 6. So your answer is going to be kind of in the middle between 5 and 6. So as a decimal, kind of in the middle is about 5.5, between 5 and 6. Moving on to the next one, the square root of 35. Where's 35 at? It's really, really close to the square root of 36. And we know that the square root of 36 is 6. So 35 is slightly less than 36. So we know that our answer has to be slightly less than the square root of 36. Square root of 36 is 6, so slightly less as a decimal is 5.9, okay? Let's compare that to the square root of 37. Well, square root of 36 is 6. 37 is a little bit more than 36. So my answer to the square root of 37 is going to be a little bit more than the answer to the square root of 36. So what's a little bit more than 6? 6.1. And that's about it. I hope this helps. We are done with this video. Good luck on the test.